All right, good morning. This is Monday, KAP, November 15th for KAP. 1 week until Thanksgiving. My class is going to be excited, so I'm going to restart the recording because I don't want their cheat. All right, let's look at this warm up. Another one of those, which one doesn't belong? What were y'all saying? What were thoughts and opinions? What did you say, Coffee? Okay, only greater than 1. Dude, what do you think? No repeating. Do y'all agree with that? Do y'all agree with that? Yep. Yeah. Okay, let's just check to be sure. What's 1/3 as a decimal? 0.3333 repeating. Very good. What's 0.6 repeating as a decimal? 0.6 repeating. Look at my bottle. Pulling you a fast one. 5/3 is the same thing as what? 1 2/3, and that's going to be the same thing as 1.6. Oh, 1.666, and yeah, it's all repeating. So I agree with what Dude said. Okay, that's a difference. What else? Anyone have any arguments for these other guys? No one?
Wait. Miss Lytle, this was the only decimal. Miss Lytle.
Yeah, Bonnie. I'm sorry, can you speak up just a little bit? It's the only percent. I agree with that. Only percent. What else?
This is the only one that has a 1.
Who's that? Me. Anything else? Yeah. That's right. She's on my level. I love it. Only one with a 5. Only one with a 5. What else?
This is the
Oh, yeah. Come get on my left. Yeah, go for it.
This is the only one with a 6.
Okay. Yep.
33 is the only one that has 2 numbers.
No. 2 repeating numbers. Yeah, I like that. Y'all see that? Like, it's not repeating, but it is. Yeah. No. It doesn't have a 3, right? Let's keep going. What else did we say?
It's the only one that has 1 and 3.
1 and 3, very good. I would say like, oh no. This is the only one that's greater than 1. I would say like this is my smallest number. What am I doing? Okay, I don't know. That's my smallest number. Which one's my biggest? 5/3. All of them are positive, so that's nice. Okay, there's these things aren't to like be a right or wrong answers. It's just what can you get out of them. Okay, and sometimes you can make them spicier and spicier and spicier. Just have fun with it. Okay. All right. I hope y'all are awake. Are y'all awake? Are y'all actually?
Barely.
I'm saying barely. You are. Just as a few reminders before we get into today's tips, a few reminders, and you'll just hear these if you're at home. So we have a lot of assignments that have passed or are coming. For Miss Lytle, if you didn't do that quizzes last week and you did it over the weekend, please make sure you message me. I have a ton of messages that I need to get through, so I will update those grades. The 1-pager from last week, again, I saw like, I think probably 70 of y'all have shared with me because I have so many emails, I just haven't gone through this. But if you're sharing that with your teacher, or if you have not shared that with your teacher, make sure you have. Oh, here's my to-do list. There is a test review that's due when this week? Wednesday. I've not done my calendar, I apologize, but due on Wednesday. And then that Canvas quiz is due Friday. Okay? Got lots of stuff going on. Remember, the reason why we're cramming so much in is because this 6 weeks is short, and so we have to get in the grades where we can. And this is how we're doing it. We're trying not to assign anything over Thanksgiving break. Okay? So you just have to put a little extra in. Yes.
Where's that chart right?
That chart means nothing. That was for one of my other classes. Unimportant. All right? Y'all good? All right, let's hop into today's notes. Today's notes should be very, like, it should flow with what we've been doing. Yes, ma'am. Okay, I don't care. I'm on my notes. Thank you for pointing out my flaws. All right, so again, today's lesson should flow very nicely from what we did last week. Today we're going to be talking about circle graphs. Have we seen circle graphs before? Yes. Guess what it is? It's a pie chart. Okay. Very good. With pie charts, all the percents add up to 100. Very good. And so we're going to keep using that stuff. So a graph that displays data as parts of a whole is called, this one is going to be called a circle graph. It's not the only one to do that, but it's the one that we're looking at today. And a circle graph, the percents add up to, wow, I just thought of that. And since the entire circle represents the whole, very good. It's going to represent the whole. You can solve problems using data represented in circle graph, including, what is that supposed to say?
Part to whole.
Part to whole, including, so we're going to talk about part to whole kind of problems. Where you're comparing a part of the problem to the whole thing. Okay? So you can solve problems using, okay, what's that awesome word that Miss Little loves so much? Proportions are going to be helpful in this case. Remember, Miss Little likes to teach you one thing that's going to work a multitude of ways. Hey, who can help set me up a proportion? Yes, Michaela. Percent over 100 and part out of the whole. Could I switch those sides? Absolutely. How do I get from one number to the other? What was that thing called? Scale factor. But yes, I always want to work towards my x. You're good. You're good. I love it. Okay. So looking at this, we're probably going to use this graph for a few problems. Number one, a total of 250 students were surveyed. How many more total students were surveyed that prefer pepperoni? Okay, so let's break that down. I see what things in there. What do y'all see? What's important information in there? There's a whole of 250. Very good. What else do I see in there that's going to be important? Pepperoni is going to be important. What else? I'm going to need the percentage of pepperoni, and are we going to test over this?
How many more of this?
More? I'm going to have to subtract. What am I going to subtract? From, we're going to separate those two. So there's a couple ways you can do this problem. What do y'all want to do first? I'll face my method too based off of y'all. What do you want to do? You want to, okay, we're going to do proportions both times. Okay. What do we want in our proportion? This is method one. What do you want in your proportion? Okay.
And then 250 is a whole.
Okay.
And 9 goes on the bottom.
Very good.
And then the top is the x. And then tell me how many times the 100 will go to 250.
And guys, can I get there? Yes. Is it going to be a whole number or a decimal fraction? Decimal type fraction. Could I simplify? Yes, but let's try and do some spicy. 100 times what gives me 250, Anthony? 2.5. Very good. Times 2.5. Whatever I do to the bottom, do to the top. Take a second and do that. Do not set up the answer, but go ahead and do 2.5 times 30. Give y'all a second. What y'all get? Awesome job. Okay, is that my answer?
No.
Oh, why not? I have to subtract. Tanner, what do I need to subtract?
The whole from number of pepperoni.
I need to do the number of pepperoni from the whole, but yes, okay, it does make a difference, and yes, I am pretty picky. So I need to do 250 minus 75. Go ahead and do that. Michael, you got your answer? Gotta be working, y'all. Carrington, did you solve? What'd you get? 175, y'all agree? I do too. 1, 14, 10, 5, 7. Very good. Okay, so 75 is my answer. Now, Ms. Lama said that's method 1. What is another way I could have solved that? What is another way I could have gone about solving that? Did I have to do that order, or could I have done something else? Okay, let's think about it. I have two steps that I did. First, I set up my proportion, and then I did one at the very end. Subtracted. Could I switch that order? Yeah. What would I need to do? Yeah, what would I subtract? If I subtracted first, what would I be subtracting from 1? Method 2. Okay, again, in here, I solved for how many people were in pepperoni, and then I said, this is how many more. Many more. Could I figure out how many more there were first? How many people picked pepperoni? 25. Before that, if I had never seen this problem before, how many people? 30%. Okay, as compared to what? 100. So couldn't I have subtracted 100 minus 30% first? And what would I get? 70%. And so that's going to be 70% of the people. But do I know how many people that is? No, but I can use what to help me? How can I figure out what 70% of that whole thing is? A proportion. Very good. Maria, can you set that up for me? Very good. And then what else do I know? I know something else. That 30 is not important anymore because I've used it. Do I know like my part or my whole? Dude. Oh, yeah, 250 is my, it's still my whole. It hasn't changed. 250 is still my whole. Now class, how do I get from 100 to 250? Times 2.5, whatever I do to the bottom, do to the top. I mean, y'all wait up, just for these guys, okay? 2.5 times 70. You want to do it with me, or y'all good? I'm good. Okay, I'm just checking. My good bunch. We get 100. Did I mess up? Oh, this should have been 175. Shouldn't it have?
Yeah.
Why did we just now mention that, y'all? I need y'all to wake up. If I make a mistake, y'all have to let me know. Natalie, you didn't bring down the 1. I'm sorry. Okay, so it should be 175, yes?
Yeah.
Okay. Go ahead, do number 2 since y'all are so lively. Pause and play when you're ready at home. All right, a total of 250 students were surveyed. Oh, no, I already read that. A total of 250 students were surveyed. What fraction of the total number of students preferred lunchroom as their favorite topic? What's the key word about my answer in this question? What is the key word, Steven? Well, that's important, but something more important. What fraction? So my answer should be a fraction. If you put a whole number, is that a fraction? Okay, so let's look at it. Total of 250 students for today. What fraction of the total number of students prefer mushrooms as their topping? So what are we looking at? We're looking at the total and we're looking at the part, and the part that we're looking at is the mushrooms, okay? Sometimes it helps to label your proportion mushrooms over your total. Okay, total. Do I have a number? Ava, can you set up this proportion for us? 20 over 100. Very good. 250. Class, I hope you know by now what's that scale factor be? 2.5. And because y'all are rock stars and notice that I already solved this, 2.5, what do y'all get? 50. X equals is my answer just gonna be 50?
No.
No, what is it gonna be?
It's gonna be 1/5 on a simple house.
So
But how would I go to 1/5? What would I do, yes, to get to 150? 50 over 250, because it's asking the fraction of the mushrooms out of the total. What can I do with that fraction? Divide it by what? What else? What else? 25, what else? 5, what else? 1, what else? 10, 2, okay. I want to make sure y'all are practicing those things, all of them, but the biggest one is 50, very good. Okay, divide by 50, divide by 50, and that gives me 1/5. Hey, guys, because it's a proportion, that means both of the sides are the same. Could I have just simplified 20 over 100? What's 20 over 100 simplified down to? Did I actually have to solve for 50? I didn't, but I definitely understand why you did. But that's the whole point of proportion, is that it's showing that it's always going to be the same on both sides. Okay, so what is the fraction that represents 1/5 of the students? Are we good with that? Okay, if you did put 50, make sure you go back and fix that. Yes, sir.
that's always the part.
No, it's not always the part. Last week we did some practice where the X was like, it said 25 is like 40% of what number, and we had to figure out what the whole was. Okay, how could I get there?
That's always like
For the most part, yeah. Okay, we'll put X in some equations and stuff. Okay, number 3, have y'all done it, or do you need time? Need time, ready, set, go.
Yep.
All right, a total of 300 students were surveyed. What fraction of the total number of students prefer cheese as their favorite topping? Help me out, please. Can you help me out on this one?
35 over 100.
And you said 35 because that's the cheese. 35 over 100, very good.
X over 3.
Very good. From there,
The scale factor is times 3.
love that. And you got
105.
105, y'all agree?
Yeah.
Yes, but we go back to the question. It says, what fraction? So what should I do? Divide. I'm going to divide either one of those. It doesn't matter because remember, those are the same thing. 105 over 300. I can divide them both by 5. I can divide them both by Anthony. What did you say? Okay, 1 second. You said? You said 3 is correct. Do y'all remember how to tell if numbers are divisible by 3?
But
You adding the, no, give me a second.
the 1, 5.
Very good. Exactly. 1 plus 0 plus 5 is, 1 plus 0 plus 5 is 6. Is that, hey, don't talk there, okay? Is 6 divisible by 3? Yeah, so that would work. 3 plus 0 plus 0 is 3. Is that divisible by 3? Yeah, so it is correct. I just prefer 5 because it's bigger. Okay, let's divide them both by 5. What do I get?
I think it's 7 over.
Let's see. That's gonna go twice. 21 is 60. Can I divide those by numbers? Tanner, what can I divide them by? I'm sorry? Divide by 3 because of that same rule that Michael just helped us with? Yes, Tanner? Yes, we could have, if you divide by 2 separate things, it's also the same thing as dividing by 15. That's 5.
I used that trick you showed me before.
What did you use, Michael?
I just went straight with it. 5.
5. Very good.
And then gives you 7 over 5.
Yeah, because I just pointed that out. But either way you do it, you get 10 points. Gucci? Okay, one last thing. Turn page. Okay, so in that, we did part to whole comparison. That's what we did right here. We were always comparing one of the parts to the whole thing. We can also compare parts to different parts. We can make what's called part-to-part comparison. I'll do one with you, and then honestly, I'm going to let you be free for the rest of class because you're beautiful individuals. Beautiful. Phoenix bird.
Yeah.
I don't know. Okay, registered automobiles. Right. A total of 79 million automobiles were registered in this state. How many more automobiles were registered in Texas and in Florida? What's that keyword we see? More. How many more? So that means that we are going to subtract at some point. This title likes to subtract at the beginning because how many times have we made mistakes where we forgot to subtract in the end? Okay, let's be honest. Yes, I love to see the hands I'm seeing of the honest people. The rest of you, you know it happens. Okay, it's always better to subtract first if I can. What am I going to subtract in this case? What am I going to subtract? Yes, Texas and Florida. Very good. So I know that Texas is 23% and Florida is 19. Let's go ahead and subtract those so I don't forget to in the end. That answer would be 4%. The other reason why I do this is because instead of finding like the number of Texas automobiles and the number of Florida automobiles, I don't have to do two separate proportions. I can just do one in this case. Okay, so I need to figure out what 4% of that is. Nicholas, can you help me set up that proportion? Again, we found that the difference was 4%. What do I need to do from there? 4% over 100. I'm going to do it on this side just because. And then what's going to be on the other part? Let's write down. Yeah, is that the top or the bottom?
At the top.
Oh, you're talking, sorry. Was it you? Oh, sorry, Nicholas. Right? Okay, were you talking? Okay. Yeah. The bottom, very good, because it says total of 79. I'm just going to put 79. I do know it says 79 million. Okay, this is the first day that we see something special. Okay, we've been working which direction with our scale factors? Side to side. Okay, I don't know if y'all remember this, but on the first day, the cool thing about proportions is you can also work up and down. Okay, I always though want to work towards what? I always want to work towards my x. So let's look this way. What do y'all see there? What do you see?
So I think you divide the top by the bottom, and then on the bottom.
Oh, not quite.
So hard. I think you like 100 by 4, and then I got 25, and the same way I divide that by 79 by 25, and that'll see that.
Exactly. If we go from 100 to 4, would I be multiplying or dividing in that place? Dividing. I would be dividing by 25. And that is totally allowable in proportions. That's the cool thing about them. We're getting into the multiple various things. Okay, but what I do to one side, I have to do the same thing to the other to keep it proportional. Okay, so 79 divided by 25. Let's do it. 79 divided by 25. Is this going to be a whole number or a part number? Decimal type thing. Okay, just 25 going to 7, but it does go to 79 3 times to give me 75. My difference is 4. What do I do? Okay, goes into 40. 1 time. I'm left with 15. I feel the end is near. 25 goes in 6 times. Okay, so my answer is 3.16. But it's not just 3.16, it's 3.16 million.
We just went up.
What do you mean we just went up? Okay. Are y'all okay with that?
Yeah.
Okay, so proportions, you can work not only side to side, but up and down as well. For the next one, I'm just going to let you know that you will need to round. Let's round to the nearest 100. I believe it's like repeating numbers, so I'm just going to let y'all know. But then, honestly, for the rest of it, finish the packet. Okay? Ready, set, go. a ratio. Again, we'll talk about these very soon. A ratio, I mentioned, did anyone remember what I said before? A ratio is, it's a comparison of two numbers. Oh, sorry. It's a comparison of two numbers. So right here, it says compares the part of the automobiles that were registered in New York to the part of those registered in California. So you're going to compare basically New York to California. When we do comparisons, we can write it as a fraction. So I'm going to do like New York to California cars. Okay, it's a little bit different than a part to whole. We're usually doing the part over the whole, but in this case, they say to write a part to a part. So what's the part of New York? 14. And what was California? 44. Okay, so we've written that as a, what kind of number is that? A fraction. But what can we do with that fraction? Simplify. We can do what to both sides? Work both numbers. Divide by 2. Let's do that. Gives me 7 over 22. Do we get any smaller? No. Okay, so that's one of the answers, but it also wants a, well, no, that is a ratio. Okay. It wants it as a, and a, okay, decimal and a percent. Maria, how do I turn fractions into decimals? There you go, 722. Does it go in? No. Does it go in? How many times? 3 gives me 66. I'm left with 4. Add a 0, bring it down. 22 goes in. 1 time. Goes in. Y'all ready for turkey time? I can tell. 18. Add a 0. Bring it down. 5. Sounds good. Okay, so that's going to give me 5. 110. It can fit again. 7. Let's try 7. Oh no. Okay, Arthur, what did you say? 22 times 7, 14, 15. Can we go in another time? Let's add it. 6, 7, yeah. So that goes in 8 times. I'm going to stop there because Miss Lada said, let's just do it to the nearest 100. I'm going to let you know anytime you have, well, no, I'm not going to let you know. It's just going to go on for a while. Okay? So if I wanted to round that to my nearest 100, that would be 0. To the nearest 100 would be 32 because 100 is 2 spots and that 5 rounds it up. Very good. If I want to turn that decimal into a percent, that would be, let's try and remember. Dr. Pepper, thank you, Tanner. That would be what percent? 32. You could put 31.58 because we didn't go that far, but again, if we're rounding, that would be 32%. That's not going to be an exact answer, but it's going to be about. What about? Did we do the right math in there? Was that 5 right? Y'all. That 5 isn't in there. Why did y'all tell me that I'm making math? That means nothing. Clearly, okay. I'm not going to work through the rest of it, but y'all are good to go. Oh, there's 2 references on there. Y'all work on this? Thank you. Homework. Do y'all have this? Okay, give me a second. All right, this is going to be your homework. Whatever you don't finish, also work on the canvas quiz. And that's for you. Thank you and good night. Good night.